So in this video I will be discussing Codeforces round 966 ready for division 3. So I will be solving first 5 problems of this set. Let's start with problem A, that is primary task. So in this question we will be given an integer n, okay, and we have to tell them whether this can be represented in a form of 10 to the raised power something such that the value of that number should be greater than 100. Okay, so this is the problem. So let me explain you here. For example, this is a 10 to the power 19. So in the question it will be given to us like 1019. Okay, and we have to tell them whether this can be represented as 10 to the power something or not, and that value of 10 to the power should be greater than 100. Okay, if this is true, just return yes, else return no. Okay, so there can be many ways to solve this problem, but how I solved this using the STI function in C++. So I think so this was pretty much easy. There's no need of explanation in this. So let's now discuss problem B, that is sitting in a bus. So in this question we are given a bus which is having n seats number from 1 to n, and there are some rules to sit in a bus. What is the rule? Like if there are no occupied seat in a bus, a passenger can sit at any seat. Okay, but if there is at least one passenger already sitting in the bus, then the next passenger should sit at the index I minus 1 or index I plus 1, where I is the index of the already seated person. So we are given a sequence in uh, we are given a sequence in which the people came and sit on the bus. So we have to verify whether is it the correct representation or not. So this can be also be very much easy solvable, but how? We can just maintain two variables, min index and max index, such that minimum index will represent the person sitting on the minimum possible index, and similarly for the maximum, which will represent the maximum possible index on which a person is sitting. And for the every new customer coming or every new person coming, just check if it is max plus 1 or else, or if it's minimum minus 1, and update the min and max accordingly. So this is also easy, so I will not be explaining much more in this question. Let's now discuss the last problem, C problem, that is numeric string template. Okay, so in this question we are given a array A, okay, which will be containing n integers. Okay, and we will given total number of m strings also, and we have to verify whether each and every string would be correspond to my given array or not, and how it will be correspond. So the condition are very much simple. The length of both string and array should be equal. Okay, done. And also that if there are same numbers on the same index, then for SO5 there must be same character on this index for that particular string. If these conditions are true, then just return yes for that particular string, else return no. So we will be given a stream of strings. Just verify whether they are valid or not with respect to given array or not. So this is very much straightforward, and I guess so classical problem. So let me show the code also, not explaining it much. So first of all, take the input and take the input array. Okay, done. Next, take the string array. Okay, done. Now, if a number of distinct characters in your given array exceeded 26, then obviously answer never be existing, because there can be no more than 26 character in your string also. So if this is a case, just return simply no for each and every string. Done. But for each and every string, when your distinct numbers are less than 26, in that case what you have to do, just simply call this function f. And what is this function? This function is just simply maintaining a map, and in the map we are just checking if the in the map we will be maintaining a int comma character, where the integer represent the your array of integers and character represent the corresponding mapped character. Okay, if your if that number has already been occurred in your map, then check if the previously mapped character to that number is same as the current one. If it is same, then do nothing. If it not same, then it is not the case, just return false. But if we never encountered the current number in our string, in our array, then check if the corresponding character has been previously occurred. If the corresponding character has been previously occurred, just return 0. Else map the corresponding character to the number and insert in the set also. So that's how you can solve problem number C. Let's now discuss problem number D, that is right, left, wrong. Very much interesting. So let me explain you the question over here. So for example, in this question we will be given a string S and a integer array A. Okay, so what we have to do, we have to select any two indexes in this array such that the corresponding character in your string should be L and R. Okay, the left one should be L and the R, and the right one should be, and the left one should be character bigger L, and the right one should be character bigger R. Okay, so just select these two indexes. Done. Okay, now after that, what you have to do, simply just sum all of them up and store in your some container like that. But there is a catch, like it was the, I think so, confusing part of this question. Let me explain you. Okay, just leave it here. I'll explain you here only. For example, these are the number given to you. Okay. Okay, done. And the corresponding mapping of the string is given to you like like that. Okay, for example, R again L, R, and this is L. For example, this is again R, L, and R. Okay, what you can do, you can either select these indexes. Okay, you can select this index. Okay, you cannot never select R and R. Yes, L and L similarly, and similarly R and L. You can only select left and right. Done. Okay, but after selecting left and right, what you will do, you will simply add 5 plus 3, because these are the corresponding numbers in your array. So just add 5 plus 3, 8 in your answer. Done. And erase this L and R, which means you cannot select this L and R again. Okay, but if you now select this L, and for example this R, then would this 5 and 3 will be counted again? Yes, this will be counted again, because only L and R are removed. Your 5 and 3 are in the array itself. So you will add this sum in your 8. This 8 plus the sum of this subarray. Okay, hope so it is clear to you. So this is the thing which you have done in the question. Now we have to return the maximum possible sum after performing some number of operation. So this is the whole question. So how to approach this problem? I will explain you using this uh, statement only. So just maintain two pointer, one pointer on the left and one pointer on the right. Okay, done. Now check if your current left pointer is left or not. If it is not left, just move the pointer to the next. Okay, just moving to the next. Now it will be at this point. Okay, done. Similarly, your right pointer is at left. Is the left valid for the right? No. Just then move it towards inwards. Okay, now it is right. Now it is left. Now your left pointer is on left and your right pointer is on right. Okay, now what you have to do? We have to just add this sum in your answer. Okay, okay, I will add this sum in my answer. So one more thing, I will be using prefix sum approach for finding the subarray sum in O of one time. Okay, done. So after that, what is the sum? That is 8. Okay, 6, 7, 8, 9. So 19. Okay, 19 plus. Now again, what I have to do? I will again shrink my subarray size. Okay, now my pointer is as this. Okay, and this is at this. Okay, these are both invalid. I will shrink them again. Now my right is at right and my left is at left. Now what I will do? I will simply again add the subarray sum of this subarray. Okay, done. Now what is the sum? The sum is 5, that is 9. 19 plus 9, that is simply 28. Okay, so okay, done. Now when I am getting a subarray, I will just decrease my left and decrease my right also. But here you can see these both come at the same position, and this is not a valid case. So your answer is 28 in this question. So that's how you can solve the problem number D. Just maintain two pointers left and right, and keep on decreasing your left pointer till you don't occur left in your string, and similarly keep decreasing your right pointer till you don't occur right. At any point, if your left is left and right is right, just add the subarray sum using the prefix sum approach, and again just decrease your left and decrease your right, and use the same approach again. So I will show the code. Okay, I am just first of all making a prefix sum, just maintaining a prefix sum for the subarray sum in a O1 operation. Now what I will do, I will just maintain two pointers, left and right. Okay, if my left is not equal to left, just increase my pointer. If my right is not equal to right, just decrease my pointer. But if both the condition are satisfying, just add the sum. What will be sum? For example, in let me erase this part. You want to find the subarray sum of this subarray. The subarray sum of this subarray is simple. For example, this is my prefix sum. Okay, let me count it also. Let this is 3, this is 8. Okay, now this is 11, now this is 16. Okay, 16 plus 3 19, again 20, again 22, again 22, and next is 25. Okay, now to find prefix sum of this subarray, what you will do, you will just add your right part in your sum and decrease left minus 1 if left minus 1 exists. Okay, what I will do, I will add 2 and I will subtract 3 because my subarray is this. My subarray is this. But I will add simply right pointer and decrease the left pointer. That is 22 minus 3, that is 19. Okay, here you can see the subarray sum was 19 only. So that's how you can use the prefix sum approach also. Just maintaining a prefix sum, adding the right pointer. If left pointer exists, then decrease that, and I plus plus j minus 1, j minus minus, and just return the sum at the end. So this is how you can solve the problem number D. Let's now discuss the last problem which I was able to solve in the contest. That is E, Photoshoot of the gorillas. Very fancy problem. But in this question, you will be given a grid, okay, a jungle, whatever you can say. So let's just skip the part. I will tell you the question problem statement only. For uh, for example, this is the grid given to you. Okay, okay, okay. For example, this is a grid given to you. Okay, done. Now there are some random numbers to with you. For example, the random numbers, let it be 5, 3, 2, 0, and let it be 9, let it be 7. For example, these are the random numbers given to you. Now you have to arrange these numbers in this grid. Okay, I will arrange, but what is the condition? You will be also be given a integer k. Okay, for example, in this question, let k be 3. Okay, let k be 3. Now what this k represents? K represents you have to take the subarray sum of each and every subarray of size k. I can say some matrix also. Like what you have to do, you have to add the after placing the numbers in this grid. For example, I am placing 5 over here, 3, 2. Let me change the color only. I am placing the numbers randomly, not in the correct order in which they should be. For example, this is the order which I am following to place the numbers in my grid. The rest of the numbers will be automatically be 0. Done. Okay. Now what you have to do, you have to calculate the submatrix sum of each submatrix of size k in this grid, and it is sure that k is smaller than minimum of n comma m, that is row comma height. So first of all, find the sum of this subarray, this submatrix. Okay, then this submatrix. Okay, then this submatrix, then this submatrix, and similarly for each and every possible submatrix of size k. After that, you will be having a sum, and that sum should be maximized. Okay, and you have written that maximize sum. But what is that maximum sum, maximize sum possible? Okay, hope so the problem statement is clear to you. Okay, so what is coming to mind, what is coming to your mind after hearing about this question? So it can be easily proven that the largest number should be on the that cell of the grid which is contributing maximum, which is coming maximum times in this sum matrix game, in this adding sum matrix time, sum matrix operation. For example, first I will add this sum matrix. Okay, then I will add this sum matrix. Okay, I think it is mess up. First I will add this sum matrix. Okay, it's the sum of this submatrix. Then I will add this submatrix. Okay, then this submatrix, and then this. Okay, done. And similarly, then this, then this, then this, and at then this. Okay, I know they're remaining. This is also a part. Hope so you are getting the point. I'm talking about this superset, by the way. Okay, so there will be many grid possible, and what you will do, you will try to place the maximum number in this stream at that place which is contributing maximum time in this some matrix operation. Okay, but how you will calculate that count? That is also very much simple. For example, I want to calculate the how many times this will be contributing, this how many times this cell will be coming in this sum matrix game. Okay, done. So how you can calculate? So you can simply maintain the top, this is top, bottom, left, and right pointers. Okay, and what will this represent? This will represent the maximum point at which my sum matrix, the maximum height means the maximum height my sum matrix can gain such that this cell is included. So tell me, what is the height? The height for this is this. Okay, so I think so I can extend the matrix for the better understanding. Okay, so let me extend it from here also. You can skip the part if you want. Okay, done. Now tell me how many they like tell me what is the maximum, what is the maximum possible, what is the maximum possible uh, row of, what is the minimum possible row of that sum matrix in which my this column will be there. Tell me, that is I is equal to 1, I is equal to 1, yes, because you know, if I am taking I is equal to 0 and k is equal to 3, remember k is my 3, so the maximum possible place is at this only. This cell will never be included if my I is equal to 0, but if my I is equal to 1, this cell will be included. Okay, so the minimum possible height in which my this cell can be included is at I is at index I is equal to 1. Similarly, find the maximum possible height. Find the maximum possible I. That is I is equal to this. What is this? 0, 1, 2, 3, 4, 5. Yes, 5. Okay, done. So 5 is that maximum possible row in which if I am making a sum matrix, then this cell will be included. You can see that if I am making a sum matrix like this, okay, if I'm making a sum matrix like this, then my this cell is included, my this cell is included, my this cell is included. But you will notice one thing, in this sum matrix my cell is not included. Yes, that is not included. So that's why I will maintain left and right pointer also, because this is top, remember this is bottom. Now I will calculate the right and left pointers. Done. For finding the left and right pointers, the approach is same. What is the maximum possible right point in which my sum matrix will be there? That is at this point. You can see my cell is coming, my cell is coming, yes, and my cell is coming. Okay, done. So my j is here. What is j? Here 0, 1, 2, 3, 4, 5. Again j is equal to 5. Done. And what is this? This is your right pointer, right maximum value. And similarly, your j minimum j would be 1. Yes, because this is the point, because in which your in this your cell is coming. Okay, in this your cell is also coming. Yes, in this your cell is also coming. Yes, but if you try to make some matrix using I is equal j is equal to 0, then you can notice your cell is not coming. In any case, your cell will not be coming if your j is equal to 0. So the pointers are defined, that is top, bottom, right, and uh, this is left and this is right. Okay, done. Now after that, what you will do, you can simply just calculate the answer, like how many times this will be included. That what is it, how you can calculate? You can simply calculate bottom minus top plus 1 multiplied by right minus left plus 1. Okay, and what is the value in this case? That is 5 minus 1 plus 1 multiplied by, okay, let me make a bracket. First of all, multiplied by 5 minus 1 plus 1. Okay, done. So what is this? This is 25. Okay, which means there will be, yes, which means there will be 25 grids possible. There will be 25 grid possible in which my this cell will be contributing. Okay, hope so this is clear to you. Hope so this is clear to you. So for each and every index you will find this count. Okay, and then whosoever cell is having the maximum count, you will just assign, what you will do, you will just multiply that number with the maximum possible number, because that's how you can get the for example, let me take the case, one cell is contributing 25. Okay, this cell is coming 25 times. For example, this is hypothetical case. Next cell is coming, for example, 22 times. Next cell is also coming 22 times. Next is also coming, only coming 15 times. Next is coming only 2 times. Okay, so how will you arrange these numbers? So the maximum number will be at the maximum possible count across cell. Then okay, I think 9 is there, maximum possible 9. Then here it will be 7. Then here it will be 5. Then 3, and then 2, and last is 0. That does not even matter. So just multiply 25 with 9, 22 into 7, 22 into 5. Okay, I can change the color. Just multiply the corresponding numbers, and this, and you will get your final answer. Okay, so hope so this is clear to you. I will show the implementation also. So just take the input array and sort the height in the reverse order, because at your zeroth index of the height, you will get the maximum height possible. Okay, done. So for each and every cell, find the top, bottom, right, and left. Just I have mentioned. So these are the basic formulas. You can just debug it and find how they are working. This is simple, by the way. So you will just add the contribution of that index of that cell in the contribution array. Okay, I'm just maintaining a okay, I'm just, this is also complicated, I think, so this is used for a unique value given to for each and every cell. Okay, using this formula you can give a unique value for each and every cell to your grid. Okay, and assigning the count. Okay, done. Now what I will do, I will just I will just sort my contribution in the reverse order only. And remember the thing, I've already sorted my height in the reverse order, which means at the first index I am getting the maximum possible number. Okay, for example, in this case is 9, and similarly I have also sorted my count in the reverse order, which means my contribution is also highest and my height is also highest. I'm just multiplying them and adding my answer. So, and you can print the answer. So that is how you can solve the problem number E. If you have any doubts in any of these 5 problems, you can comment me down. And please don't forget to subscribe to my channel, and please do like, share, and subscribe. Done. Okay, so thank you for watching. Stay tuned for the next one. Thank you.